The reason we do that is so that we get 3 different samples. We get it from the bottom, the middle and the top, so you have a representative. And that would all get mixed up together then. When it goes to the lab, that'll all get mixed, but you'd get a representative sample.
During harvest time, mussel samples are sent to the Marine Institute in Galway twice a week. The mussel flesh is carefully removed from its shell and is cut into small pieces for chemical analysis.
In the month of October 1995, we took some samples from Killary Harbour on the west coast of Ireland and analysed these. We also got reports that some people had gotten sick from a consignment of these mussels that had gone to the Netherlands. So we did a lot of testing on these shellfish, but we could find no toxins. None of the known toxins were present in that consignment of shellfish. So this was very puzzling. Why were people getting sick?
Researchers were unable to identify the toxin present in Simon Kennedy's mussels. None of the known algal poisons matched the samples. The 8 victims from the Netherlands must therefore have ingested an unknown toxin. Its chemistry was only identified 3 years later by a research group in Japan.
At the time, because we didn't know any better, the toxin was called Killary toxin initially, but subsequently when they characterized the actual molecule, they found the chemical constituents of the molecule, and it was called azospiracid. So this is the toxin now that we have.
Scientists have developed a new detection method for the presence of azospiracid. This test has become a cachet both for the farmer and the consumer. Simon Kennedy understands the importance of this research through first-hand experience. In 1995, he was the first victim of azospiracid poisoning.
Well, it would feel like a 24-hour bug. During that 24-hour period, you did feel pretty darn bad.
In Sorsogon City in the Philippines, the red tide has been poisoning the bay for years. Often the mussel farmers need to find new livelihoods. Some of them turn to fishing, while others collect garbage.
Ako si Roger Pariha.
My name is Raja Pariha. I am 56 years old and am a city official in this district. A few years ago, the Bureau of Fisheries and Aquatic Resources initiated a new source of income for the area, namely mussel farming. This initiative provided new livelihoods for people. A farmer would get up to 600 pesos for 1 bag of mussels. When the red tide hit, the authorities prohibited the harvest, trade and consumption of mussels. The consequences of this prohibition were disastrous for the mussel farming community, but we respected it. Many of us suffered during this time.
Impact dito sa aming barangay. Marami talagang naghihirap.
Despite the presence of the killer algae, mussels are still being consumed in the slums. The problem? The toxins remain in the mussels even after extensive cooking or the addition of spices or alcohol. The slum dwellers can only use a primitive method to test their food: trial and error.
Sometimes people here have nothing to eat other than mussels. They cook the tahong mussel, and before eating it themselves, they feed some to their pets, mainly cats and dogs. If the pet dies, the mussels should not be eaten.
Yet the animal food tasters provide a doubtful protection. Sometimes only a few single mussels contain a deadly dose of the algal toxin. Vicente Cerrillo lives in a slum just outside of Sorsogon City. He collects garbage and exchanges recyclables for rice. 1 year ago, when his brother-in-law brought some mussels for them to eat, the feast ended in a disaster.
Ako po, si Vicente Cerrillo, linuto ko po yung tahong, lininis ko.
I washed the mussels and boiled them. I gave them to my children to eat. We all ate them.
Kami lahat kumain. Nung matapos namin kumain, siguro makalipas
About 4 or 5 hours later, one of my children began to vomit.
Susuka na yung
A little while later, my other child also vomited.
Tapos sumabay na rin yung isa, naging dalawa na yung pagsusuka ko. Dinala ko na sila sa
I took my children to the hospital in
Sa
Sorsogon.
ospital, Sorsogon, Provincial Hospital.
My youngest child died within 1 hour,
Patay na yung isang anak ko, yung
and my other
bunso.
child within 3 days.
Pagkalipas siguro ng kuwan, dinala namin sa Legazpi yung isa. Mga 3 araw siguro yun. Namatay na rin yung isa kong anak.
The Alfred Wegener Institute in Bremerhaven, Germany is one of the leading research centers on toxic algae. Over 10 years, scientists have tried to isolate the organism which produces the newly discovered Asis peracid. The toxin had no known source, no algae associated with it. But then, in 2007, while analyzing a water sample from the Scottish coast, researchers discovered a minute organism that had so far slipped through the plankton nets. Alan Simbella was the head of the research group that made the discovery.
It's a bit like a detective story. You know, what we have is we have victims. That's the people that were poisoned. We know what the poisons are, but we don't know what the perpetrator was, who he was actually. Now we know who's caused the problem. What we want to find out now is where is he? What we need to do now is to determine, in fact, what about the causative organism? How widely is that distributed? Because we're really only looking at the footprint of the organism.
Urban Tillman, Bernd Kroch, and Alan Simbella are preparing an expedition along the coast of Ireland. In April 2009, the research vessel Heinke leaves the harbor. The researchers will spend 23 days living on this vessel and collecting samples along the way in search of the new toxic algae. The Philippines holds some of the largest ecosystems in the world. For example, it is home to 2,400 different species of fish. The rapid increase of the population has led to the exploitation of the natural resources. The ecosystems are under a massive strain. As the population continues to grow, the exploitation of the sea will increase even further and facilitate the dreaded algae blooms. Although rigid laws have been passed to save wildlife sanctuaries, the environmental problems are now becoming a human health problem. At the University of the Philippines in Manila, scientists are studying the proliferation and consequences of harmful algal blooms.
I'm Rodora Azanza, and I'm a professor of the Marine Science Institute, University of the Philippines here in Diliman. I'm doing research on harmful algae, especially the toxic ones, because this is very important, not only in science, but also in the management of the problem in the Philippines. And we are now doing this Philippine Harmful Algal Blooms program, and we are testing for all types of toxicities so that we will be helping in protecting the people.
The main problem for Rodora Azanza and her team is the vast coastline. It is 36,000 kilometers long and makes scrutinizing monitorings virtually impossible. Therefore, the scientists need to select certain regions where the monitoring is most critical. One team of young researchers is on the way to Sorsogon City, currently the hotspot of algal blooms in the Philippines. In Sorsogon Bay, the researchers are using traditional fishing boats and GPS systems to head for 9 different location points to take measurements. Using a finely meshed net, they remove plankton samples from the water. A spectrum of tiny organisms, invisible to the naked eye, are contained in these samples. Among them, tiny crabs, bacteria, and algae. The researchers analyzed the samples that same night. They have set up a provisional laboratory in their hotel using basic equipment they carried with them from Manila. Peter Paulo Rivera has been traveling to Sorsogon City regularly since mid-2009.
We're doing sampling at the Sorsogon Bay because there are the presence of the cells or Pyridinium bahamense are present in the waters of Sorsogon Bay, and we're trying to monitor it perhaps monthly or at most, so that we can get the trend also in the counts of the Pyridinium.
Peter Paulo Rivera and his colleagues count the different types of algae under the microscope. They identify the organism responsible for red tide, Pyridinium bahamense, a small round single-celled algae. It prefers the warm tropical waters and is related to the algae Alexandrium tamarense, which looks very similar but prefers the colder ocean temperatures of North America, Europe, and Japan. Both organisms produce the same deadly toxin. A storm is brewing off the coast of Ireland. The Heinke is fighting strong winds and heavy storm swells. The German and Irish researchers on board struggle not only with seasickness, but also try to stick to their tight schedule. Their time on the research vessel is limited, and despite the storm, they need to reach all the required measuring points. When the sensitive measuring equipment is lowered into the water to take samples, it is a critical moment, especially when the sea is so rough. The CTD Rosette is a deep-sea probe that collects samples and measures temperature, water pressure, salinity, and chlorophyll content. The measurements from the probe are relayed to the control room aboard the research vessel in real time. The water tanks are shut when the chlorophyll measurements are high. The higher the chlorophyll concentration, the more likely it is to find traces of the poisonous algae in the sample. Once aboard the research vessel, the water samples are bottled and individually filtered. The filters are very finely poured and are able to hold back even the minute algae they are seeking, the recently identified algal species with a diameter of only 10 micrometers. The samples are then centrifuged and extracted. Only after this process the researchers are able to look for any poisonous chemical compounds in the samples.
After several extractions of the filter, we can separate our sample into its elementary particles using chromatography. Subsequently, I can analyze different masses of the toxins using the mass spectrometer, which is very sensitive in detecting the different toxins.
The liquid chromatography mass spectrometer, also known as LCMS, is a highly sophisticated tool. This machine first separates the samples into its basic elements and then identifies its chemical compounds one after another. For the researchers, it is of great value to have such a powerful device on board, as it is able to measure even the minutest concentrations of toxins.
Yes, very interesting. Look at these lipophilics at the back and at the trail of Asasparicid 1. Last station? Yes, last station. About 3 meters below the surface. This clearly confirms it. It's beginning. Yes, the concentration is not very high, but